Okay, so question 8. What is a hydrocarbon? Okay, so even just looking at the name hydrocarbon, we can kind of guess as to what it is. It's an organic compound that consists of both hydrogen and carbons. Okay, so for obvious reasons, hydro and then carbon. Okay, so I'll have some examples. So example, you can have a carbon that has 4 hydrogens attached to it. And this is just methane. Or you could have a carbon ring so this is an aromatic 6-membered ring that only contains carbons and hydrogens, and it is called benzene. So this is another example. Okay, so hydrocarbons, they are good for us humans because they provide energy when they undergo combustion with oxygen. Okay, so let's have an example of a combustion reaction. So typically you have your hydrocarbon. So for example, let's say hexane. And combustion reactions will always have oxygen as a reactant, and the products will be CO2 plus water. Okay, so now to balance this reaction, I'll balance my carbons first. So there are 6 carbons on our reactant side. I'll put 6 in front of CO2 to balance out the carbons. And then next, I'll balance out my hydrogens. So there are 14 hydrogens in our reactant side, so I'm going to put a coefficient of 7 in front of H2O. And lastly, we can balance out our oxygen. Okay, so if we count it out, in the reactant side, it is 12 plus 7, which is 19. So in front of O2, I'm going to put 19 over 2. But in order to get everything as a whole number, to get rid of that fraction, I'll multiply this whole reaction by 2. So this gives us 2 hexane plus 19 O2 makes 12 CO2 plus 14 H2O. Okay, so if we quickly double check, we should have 12 carbons, 28 hydrogens, and then however many oxygens that is. 19 times 2, so 38. Okay, so the junior tutor said, hydrocarbons are organic compounds that consist of carbon and hydrogen atoms. These are naturally occurring compounds that make up the most common energy resources such as crude oil, natural gas, coal, and others. They provide energy because they are highly combustible, producing carbon dioxide and water, as well as heat when burned through the use of oxygen. There are 4 types of hydrocarbons. Alkanes are single bonded carbon and hydrogen with the general formula CnH2n+2. So however many carbons you have, so let's say you had 2 carbons, to find out how many hydrogens you would have in that alkane, it would be 2 times 2, which is 4 plus 2, so 6. And then alkenes are double bonded carbon and hydrogen with the general formula CnH2n. Alkynes are triple bonded carbon and hydrogen with the general formula CnH2n-2. And then aromatic compounds like our benzene contain 1 or more rings with pi electrons delocalized all the way around them with the general formula CnHn. Yep, so this solution is correct.